welcome to Learning Java with IntelliJ IDEA. This is lesson 3, working with variables, which is a natural progression from the last lesson, which was lesson 2, where we were looking at outputs. So we're going to be doing some work around the different types of variables and why variables are important. I've got a picture I want to show you, and this picture actually represents variables in a very important way. As you can see, it's a child's toy. There's a hammer in the top right hand corner, but it's the shapes I want you to focus on. In terms of why this is so important, when you're working with variables, it's really important to declare them when you're building the variable, so you know exactly what variable type you're going to use or what data type you're going to use. Like this shape, you can only get the right shapes in the right holes, and variables work in very much the same way. You can't force a variable that isn't going to work into an area where it's just not going to fit. I want you to think of variables like this. I know some people will think of them in terms of boxes and things like that, but for me they need to be shaped as well. Boxes are great, but you can put anything in a box. So as this illustration shows you, the red square will only go in the red square space, the white square will only go in the white square space, and so forth. So it is quite easy to ensure that the right shapes fit in the right holes. And like I said, with variables we do the same sort of thing. So let's talk about variables for a moment, and I'm just going to go on to the next slide. This is working with whole numbers. So whole numbers are numbers that don't carry a decimal point, or there's no fraction. So the first data type we're going to look at is the one called byte. This is 1 byte in size. It allows you to use numbers from minus 128 to 127. So if you're dealing with a number that's never going to exceed that area, then using the byte data type would be the best type for that number. The next one down is short. Now that uses twice as many bytes. However, it gives you numbers from minus 32,768 to 32,767. So again, quite a decent spread of numbers there. If neither of those fits what you require, then the next one is int, or as we call it, integer. Now that uses 4 bytes. So again, that's double the bytes of a short. And we'll talk a little bit about those in a moment. The integer, we've got minus 2,147,483,648 to 2,147,483,647. So again, a massive spread of numbers there. That's just over 4 billion numbers available to you if you take the minus to the plus. Then we've got the long, and the long uses twice as many bytes as the integer, and I'm not even going to pretend to tell you what that number is, but it is big. Okay, that's a massive number. One of the things that we as programmers must be able to do is ensure that we're not wasting too much memory. If you're only dealing with a number from 0 to 127 or minus 128 to 127, then it makes sense that we only want to use 1 byte of memory. We don't want to use a long, which uses 8 bytes of memory. 8 times more memory, but still representing the same span of numbers. It's quite wasteful. And again, you can multiply that by 1,000,000 or 1,000,000,000. So we've got these different data types. We've got these different data types available to us so that we can keep the memory size down. So this requires a little bit of planning. You need to know more about what your numbers are going to do, what they're going to generate. So these numbers are really good if you're dealing with whole numbers. However, if you need to use numbers with a decimal point value, we're then moving into what we call fractional numbers, and these are the two data types that we use for fractional numbers. So we've got a float and we've got a double. A float uses 4 bytes of memory and is sufficient for storing 6 to 7 decimal points. However, a double uses 8 bytes of memory, is sufficient to storing 15 decimal points. Now there are other data types that are available. So we've got string, and strings are used for storing text. Now I haven't put a size value in there because the size is dependent on the number of characters you use. Now a char is a character, okay, and that uses 2 bytes of memory, and that stores a single character or a letter, or what we call an ASCII value. And there is an ASCII table if you want to have a look at that online. I've been using those for years, and basically it's a representation of all the characters that you generally use, the ones that you appear on the keyboard. And the Boolean uses 1 bit of information. Now if you aren't sure about your bits and your bytes, there are 8 bits to 1 byte. Okay, so this uses 1 bit or an eighth of a byte. That is just true or false. So those are that's the theory behind variable types. Now let's get into the practical. Okay, so if you were in the last lesson, you would have remembered this piece of code that we wrote. If you've been presented with this, let me just show you how to get out of it. So go to File, and then simply go to Close Project. Now I can see it on my project list, and I'm going to start a new project. So that brings up this project page with all these options. We're not going to use any of these options in this scenario. However, you will need to make sure that you've got a project SDK. And if you followed the first lesson's example, you would have had that all set up. Okay, so I'm going to hit Next. And I'm going to hit Next again, because I'm not going to create a template, and I'm not going to use a template either. Okay, so I'm going to give this a name. So in this case, I'm just going to call it Variables We Use. Okay, you can see it's saving it into an idea projects folder. I'm going to hit Finish, and we're going to set up a new project. Again, I'm going to go to src, just like I did in the first lesson. Right click, New, and Java class. I'm going to call this Variables We Use, and press Return. There you go. So we've got a class now called Variables We Use. The first thing I need to do is to make sure that we've got a main method. So again, I can either type in main, press return, or let me just undo that a moment, or I can use the key SVM, okay, or I can type it up. Either way, you need to have that public static void main method sitting in your application for it to work. If you don't have it there, it's not going to work. In fact, let me just go back a step. If you notice over here, there are no triangles, so we can't run it at the moment. So simply doing that, now these triangles appear, now it's given me something to run. We're going to start by using the byte, and I'm going to call this num, N-U-M. Okay, so one of the important things to do when you are creating a variable is you name it. Avoid using things like X or Y or Z. They might mean something to you when you're keying it, but later on when you go back to have a look at it, it's not going to mean anything at all to you. So you need to have a variable name that you can use. In fact, I'm actually going to use age. So age is quite a useful one, because this is going to be looking at someone's age. And in this case, the age of the person is going to be 18. The byte uses numbers from -128 to 127. So unless you're doing the age of a tortoise or something like that, this age range is perfect. Now you'll see there's a little squiggly line there. So it's basically saying we haven't closed it off yet. So I just need to put that semicolon at the end. Because we've done the output, I'm going to use the output to demonstrate the number. So first of all, we need to have a system. There's a system. .out .println, and inside here I'm just going to say age. Now I'm going to use Shift F10 to run this. I'm going to ignore that parameters there. Shift F10, and it should just run. So there you go, 18. So I'm going to make this slightly more interesting. So I'm going to put speech marks. The youngest age for an adult is, and then put a plus in there. I'm going to put a little space there, okay, and then we're going to run this again. So run that, and you can see the youngest age for an adult, looking down here, is 18. So that's using a byte. Now let me just show you what happens if you use a number too big. So we're going to use number 300, and you can see we've got this squiggly line and an angry looking light bulb over here. So I'm just going to click on that and cast to byte, it's saying. So it's saying this number is too big. So what it's saying is, actually let's just use the int instead. So if I click on that, now it's happy because I'm using an integer. Okay, now I could get away with using a short, so let's just use a short instead. And again, if I run this, it works just fine, only the youngest age for an adult is not 300. Okay, so again, I can use numbers between 32,768 up to 32,767. So let's just try and see what happens if I use a bigger number. So I'm just going to do a minus, I say bigger number, a smaller number really, minus 6,000. So 60,000, sorry. And again, we've got this squiggly line coming up. So now it's saying, look, just change it to an integer because it'll be happy. So we put it into an integer, and sure enough, it's going to be happy. So as you can see, with IntelliJ, it does actually warn you if your number range is too big or too small. And that's a really useful tool as far as I can see. Now, I can't think of anything that's 60,000. So I do know that the moon is about 385,000 kilometers away from the Earth. So let's just use that number, 385,000 kilometers away from the Earth. Now I can't use that comma. There you go. So just keep your numbers whole. Can't use any kind of spacing like commas or anything like that. The moon is on average plus, I'm going to call it distance, space, from the Earth. Like so. Now I need to put another plus in there, and I need to change this to distance because I've now renamed the variable. So as you can see, it's quite happy with that. And if I run it, I'm just going to click on that button there to run it. The moon is on average 385,000. Oh, let me pop that in. So we want km and run it again, just so you can see it. There you go. The moon is on average 385,000 kilometers from the Earth. So that worked really well. Now again, let's make the number bigger. So what I'm going to do now is we're going to deal with Pluto, the planet, not the dog. So Pluto is on average distance from the Sun. Okay, so the distance is 3.7 billion miles. 3,700,000,000,000. So once again we've got that squiggly line, so the integer is not going to be enough for us to be able to use this type of number. So now I'm going to need to change this to a long. So in order to use the long, we just change that to long. But the other thing that I also need to do is with the number, because you can see the squiggly line is still in place, I need to put an L on the end just to denote that it's actually a long number. Now if I run this application, I'm just going to do that now, run, you will see that down here, oh, it's done it, but yeah, I'm a little bit of a stickler for attention to detail, so I'm just going to put a space in there and run it again. Pluto is on average 3,700,000,000 miles away from the Sun. Okay, so that's whole numbers. So now we're going to be looking at fractional numbers, and I'm just going to get rid of all of this information first. And the first value we're going to use is a float. So I'm going to use a float and I'm going to declare it. And the name of this float is going to be pi, so the variable name is pi. And the number we're going to use is the pi number. So there you go. Now straight away we've got this squiggly line. Now just like before when we were dealing with the double in the previous example, I need to denote that this is a float. So I'm going to put F at the end. There you go. And just like before, I'm just going to system dot out dot print line, and I'm just going to put pi in there. I'm not going to play around with it so much this time. Okay, so I'm going to run it, and hopefully we'll see pi appear down at the bottom. But we're only seeing it 1, 2, 3, 4, 5, 6, 7 decimal places. So if you remember from when I did the theory, it's 6 to 7 decimal places, so that falls in very well. So let's change this now to a double. So I'm going to Change that to double, and it's really important that I end this with a D. Okay, so D for double. Now when I run this application, you'll see that this is now a much bigger number. Well, it's not bigger, but it's showing me more digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 decimal places. So just as I said before, when we do the double, it does it up to 15 decimal places. So that's really everything you need to know about the float and the double. That's a number of variables covered, so we've done the whole numbers and we've done the fractional numbers. That just leaves us with 3 more to look at, so we're going to look at the first one, which is string. Okay, so string is your characters, so you can use it for pretty much anything with text in it. One of the more common types of variables that we use, so I'm just going to give you a quick example. So let's start by getting rid of this information here a moment. First of all, string starts with a capital S. Don't start it with a lowercase s, so it's really important that we do that. And then I give it a name, exactly the same with the number variables. So let's call this one name. Okay, so name equals, I'm just going to put Joe. Again, we have to close the semicolon, so that finishes it off. And then if I use the system print line, so we'll do that very quickly, do is just type in name. And if I run this application, you'll see Joe appear down at the bottom. That's great. Okay, so what about if we have 2 variables? So I'm just going to copy and paste this variable, like so. And the surname I'm going to put as blogs. Now, if you notice, we've got this squiggly line under the word name. That's because you can't have 2 variables with the same name. So that applies to your numbers as well. Do not use the same variable name. So in this case, what I'm going to do is we're going to call this one first name, capital N, and this one surname. Now what I'm doing is, with this first name, I'm using what we call camel case. Camel case is basically a way of breaking up multiple words in a variable name. The first word is lowercase. All the words that follow start with an uppercase character. You can't use a space in between the 2 variables because it doesn't like that. What you can do is you can put an underline. It depends on the naming convention that you use where you're working, but keep it the same throughout, keep it consistent. What I tend to do is I use the first word as lowercase and all preceding words starting with an uppercase. We have a first name and a last name. So what I need to do is, because it doesn't recognize this anymore, because we haven't got a variable called name anymore, so I'm going to have to make sure that I use that. Now if I want to put them both together, you could just simply put a plus here and surname. Okay, and that would work. Let me just run that a moment. So you'll see it'll say Joe Blogs. The only problem is there's no space in between the 2. So to get around that, what I tend to do is I have a couple of speech marks and a space in between. That forces the space to appear between the 2 words. So now when I run this, you will see that we've got Joe Blogs. I'm not going to get too involved in doing the strings because we're going to be using a lot of strings throughout the lessons, but this is kind of an introduction and also a quick introduction into naming conventions. Now another variable that we can use is char, C-H-A-R. So I'm just going to use that now. And with char, we can only use 1 character. So I'm just going to do that. So this is going to be the first initial. Okay, now you'll see that we've got these squiggly lines. Now chars have a different set of rules. You can't use the speech marks. You have to use the apostrophe. So when I switch it to apostrophe, you'll see that the error line will disappear. If I run this application again, actually I can't run this application again because we don't have a first name. We have a first initial. So let's change that. So if I run this, you will see it now says J Blogs. If I put Joe up here, it doesn't like it because I'm using multiple characters. Now the final one we're going to look at is Boolean. So let's get rid of these. and we're going to do Boolean. So Boolean, like so. I'm going to do Boolean is okay. I'm going to say it's true because I am okay. So what we'll do is we'll do a quick print line of this. So normally I would go through system and so forth. What I'm going to do is I'm going to show you this. So if I use that and press return, that automatically brings in the print line. So a little shortcut for you, SOUT. And here I'm just going to do is okay. Now if I start typing is okay, you'll see that it will appear as the first thing because it's a variable that we're using. I can press return and I'm just going to run that. And you'll see that it says it's true. Now if I want to make it false, I can just type in the word false, run it, and you'll see it's false. We generally use booleans when we're trying to do a condition, and I'll talk more about conditions in the future. For now, those are the variables we've done. So at the moment you should know how to do whole numbers, fractional numbers, text and boolean. I hope you enjoyed this. If you did, give this video a big thumbs up, and also please subscribe if you haven't already done so, and you'll be notified of the next lesson that I publish. Okay, until then, thank you.